Bismillah ar-Rahman ar-Rahim, Chapter 8, Conservation of Energy. إذا بتلاحظوا if you recognize, we did conservation of mechanical energy. يعني we assume in the transfer of energy that there is no loss of mechanical energy. Again, mechanical like potential, kinetic, rotational. بس ما حكينا عن rotational, but rotational is considered also conservative energy. And we solved some problems regarding that. Now we will deal with the general concept اللي هو conservation of energy. Conservation of energy. And you know this is the law of conservation of energy, or we call it first thermodynamics law. Energy cannot be created and cannot be destroyed. It's just transferred from one time to another. So in this chapter we are going to deal with the concept. So suppose that we have mechanical energy that is conserved. However, some of the energy will dissipate. Some of the energy will be from non-conservative force, such as friction. And we will see how we are going to deal with our problem with the existence of non-conservative forces. And we have some of the mechanical energy is lost. Still we have conservation of energy in total. طيب. Well, the first situation here, exactly. Chapter 7, لاحظ يا عادل, Chapter 7 was talking about conservative forces and conservative energy. So all the energy is conserved from one time to another. In this chapter, we will deal, how about if the system is not isolated system? That means part of the energy is converted, or part of the mechanical energy is lost. زي ما حكينا, mechanical energy معناته conserved energy is converted from one type to another, and we don't lose anything to friction. However, in this chapter, we are going to consider losing some of the energy to friction, and we will see how we are going to deal with the system. Non-isolated system energy crosses the boundary of the system during some time interval due to interaction with environment. وبعدين non-isolated, so total mechanical energy اللي هي conserved could be less, could be more, could be less, could be more in this kind of system. Here we are going to deal with less, that we lose some of the energy due to friction. Let me enlarge this and go one by one. So for example, in this situation we have a block or a book or some mass, and we try to move it. So then the energy is transferred to the block by work, because the block now is moving. In this example, energy leaves the radio from the speaker by mechanical waves. So energy is transferred. So we are talking about energy system which is non-insulated. يعني energy can go out of the system, energy can come in to the system. In this example, you have a hot cup of coffee, like me. So this is a hot cup of coffee. and you put a spoon. So تفضلوا صحيح تفضلوا يا شباب. So you put a spoon in it, so energy is transferred from the hot coffee to the handle of the spoon by heat. So this is an energy transfer. Also, we can have a matter transfer. You fill your car with gas, you have a matter transfer. Here, energy enters the hair dryer by electrical transformation. So we put electricity, we get heat. Here, energy leaves the light bulb by electromagnetic wave radiation. So when we put electrical energy, it will transfer into light, electromagnetic wave, etc., etc. So that means in a system, we could some of the energy can be lost from a system. As a result, we need to consider it to solve our problem. So here in the left hand side, we have a kinetic energy, all sort of kinetic energy. We have all sort of potential energy. يعني potential could be gravitational, could be elastic, could be spring, whatever. And here we have the internal energy. So the object can get hotter, for example. Some of the energy is transferred to the system itself. And from the right hand side, we have work, we have heat, we have transfer of energy, electromagnetic wave. And here we have material transfer, etc., etc. So we can have, although the system is not insulated or isolated, yet energy is conserved. So whatever we put in the left side, we will get in the right side. We will get in the right side. طيب. So let's go to an example that we talked about in chapter 7 اللي هو isolated system. شو يعني isolated system؟ يعني total energy is conserved. Total energy is conserved. يعني potential energy and kinetic energy, the change in potential energy, this one, the change in kinetic energy must be equal to 0. That means if we start with a certain amount of energy, we have to end up with a certain amount of energy. That is isolated system. The other one is non-isolated system, so energy can enter and energy can go out. This is conservative of mechanical energy, our conservation of mechanical energy, and we talked about that a lot in chapter 7. And if you have a conservative force or you have mechanical energy, it will be conserved. It will be you are not going to lose any of that energy. It will just transfer from one type to another in an ideal situation. If you have friction, then it's not a friction force is not conservative. So we need to consider that. طيب. So let's deal with this situation. Yes, we are going to deal with isolated. Isolated, basically, that's chapter 7. Now, non-isolated is most of the cases here in chapter 8. طيب. This is isolated system. So we are going to ignore friction or air resistance or whatever. Now suppose that there is a person standing on a roof, for example, and we have three situations. Let me enlarge it. So we have vector v1, we have vector v2, and we have vector v3. When you look at it in terms of energy, he's asking us, okay, when those three different balls reach the ground, concentrate with me, what is V1, and we have V2, and we have V3. Yalla, which do you think will be higher? V3 or V2 or V1? Yaman, all the same. Ahmad, V2 is latest. V3. Ahmad Jad, the same. طيب. V3 has more distance. Well, first of all, here is the difference. Here is the difference. V1 here, it's a speed or velocity? This V1, it's a speed. This V1, it's velocity 1. This is velocity 2. This is velocity 3. But when I write without a vector, that means I'm talking about V1, speed 1, speed 2, and speed 3. You see the difference now? Okay, so now look at this. If V1 is equal V2 is equal V3, I'll give them a dash just to make them look different. What will be V1, V2, and V3? So now I give you a hint. I told you speed 1 is equal speed 2 is equal speed 3. What will be speed 1 after it reaches the ground, speed 2 after it reaches the ground, and speed 3 after it reaches the ground? Well, I will tell you, Ahmed, look at this. Look at this, يا شباب. هذا vector 1 is equal Vx cosine theta plus Vy is equal V1 cosine theta plus V1 sine theta. Correct? طيب, what's the magnitude? It is x square plus y square. So we have V1 cosine square of theta plus V1 sine square of theta, يعني V1 multiply by cosine square plus sine square theta, but this is a 1. This is a 1. So if you have the same speed, no matter what angle you choose, it will stay the same speed. It will stay the same speed. So when you apply the energy concept, then what's the energy at this point? At this point, it is mgh to the ground plus half mv square. So here, energy at the top, here, half mv square plus mgh, and here also half mv square plus mgh, because energy, it's a conservative energy, so nothing is lost. Correct? So no matter what is your angle, you shoot it like this, or like this, or like this, you will end up with the same speed at the bottom. You end up with the same speed at the bottom. So V1 is equal V2 is equal V3. Yeah, just before it reaches the ground. Well, after they touch the ground, and energy will be transferred into friction and heat and sound, etc., etc. So we say just before it touched the ground. Yeah, we are not talking about the time, Jadallah. We are talking about the speed. So Iman said, let me read your what you say. Yaman said the initial angle doesn't matter. That's correct. That's correct, Yaraman. Yeah, Yaman. So initial angle does not affect the energy, because we are talking about the concept of conservation of mechanical energy. We are talking about the concept of conservation of mechanical energy. يعني, let me give you another example, because Ahmed Jadallah mashallah mentioned something good. It's of course they will not reach the ground at the same time, but we are not talking about when they will reach the ground. Let me give you an example. We have inclined plane with a theta. We have a ball here and we have a ball here. The first ball will go into the inclined plane, and the second ball will go directly, will hit the ground. Directly will hit the ground. When it hits the ground, so this is object 1, this is object 2. When it hits the ground, V1 will equal V2. V1 will equal to V2. طيب, who will reach the ground first? Of course, the free fall will reach the ground first. But when they reach the ground, they must have the same speed, if we ignore friction. So if we consider it just conservative forces, when they reach the ground, they will have the same speed. طيب, who will take longer? Of course, the inclined plane will take longer, but we are not talking about the time. We are talking about the speed, about the conservation of energy. Okay, so this is an important concept when we deal with a problem. We look at the conservation of energy. Not same velocities, of course. Adil said not same velocities. Of course, because each velocity will have a different x component and y component, but same speed, because energy is half mv square. So energy is dealing with the speed of the object, not the velocity of the object. So when we deal with isolated system, change in energy of the system is equal to 0, so that nothing will enter and nothing will go out of the system. So the change in total kinetic energy must equal to 0. And let's talk about this. A ball of mass m is dropped from height h above the ground as shown. Neglect air resistance. Determine the speed of the ball when at a height h, or at a height y. Well, so at this point, what is the total energy? It's equal kinetic energy plus potential energy. So if it is dropped from rest, that means kinetic energy must equal to 0. Well, potential energy is mgh. طيب, how about this point? At this point, E total is equal kinetic energy plus potential energy. So at this point, kinetic energy is equal total energy, and potential energy must equal to 0. So here total energy is equal the potential energy. So that means at this point, total energy is equal half mv square. طيب, what is total energy from this? It's equal mgh. So mgh is equal half mv square. So right away m will go with m, and we end up with the relation v square is equal to gh. يعني v is equal under square root to gh. Yeah, v node is equal 0 because we started from rest. Here, start from rest. That is a standard equation for free fall. Exactly. If you still remember the old equation, the kinematic equation, v final square is equal v initial square plus 2gh. Well, at height y, V is equal to G y. And here, what is the kinetic energy? What is the kinetic energy? Well, the potential energy is equal mgy. The kinetic energy is equal half m v square. And what is the relation? Well, the kinetic energy at y is half mv square at y, correct? And how much is that? Well, we start with mgh, and this is h, and now we are at y. So change in kinetic energy is equal mgh minus mgy, يعني mg في h minus y. So half mv square is equal mgh minus y. You can eliminate m, and then it will be v to g h minus y. But the important point is to know the relation that change in kinetic in potential energy plus change in kinetic energy must equal to zero. It's an isolated system. It's an isolated system. So what's the meaning of change of potential energy and change in kinetic energy? That means E energy initial, E total initial must equal E total final. That's another way to say it's conservative and it's isolated. طيب, let's see this situation. I will give you a minute to read it and then we go through it. Can somebody read it for us? Shabab, can somebody read the question for us on his microphone?
Okay, I will read. Is my voice clear?
Yeah, it's clear. تفضل.
Alright. You are part of a stage group, a vertical company, and are designing an apparatus to support an actor of mass 65 kilograms who is to fly down to the stage during the performance of the play. You attach the actor's harness to a 130 kilogram sandbag by means of lightweight steel cable running smoothly over two frictionless pulleys as in the figure. You need 3 meters of cable between the harness and the nearest pulley so that the pulley can be hidden behind a curtain.
طيب. So you understand the situation? So basically, this actor, the mass of this actor is 65 kilogram. And this actor will jump to the stage. So from here he will move into this pendulum, and he will reach, let me just, so that's his initial position. So he'll move to the second position in this stage. Clear? Now we will talk about the problem. We will talk about the problem. Yalla, please read it for us. Let's see the problem.
Okay. For the apparatus to work successfully, the sandbag must never lift above the floor as the actor swings from above the stage to the floor. Let us call the initial angle that the actor's cable makes with the vertical theta. What is the maximum value of theta can have before the sandbag lifts off the floor?
طيب. So he's asking us that for this scene to succeed, this sandbag, which weighs 130 kilogram, should not leave the ground. Should not leave the ground. So of course, he's asking what is the maximum angle that this actor can swing without this sand bag moves up. What's the maximum angle? Of course, there must be a maximum angle, because if the player, for example, started from a very high angle, if he started from a very high angle, then when he reach the equilibrium point, or when he reach his point, what's يا عادل؟ Be careful يا عادل، لأنه يعني it needs detail. It needs a detail. So if he go too fast, if he goes too fast, so at this point, his force could be larger than the force of the bag, the force attracting the bag. So let's try to find the angle that Ahmed Abdo على طول gave us the answer. So let's analyze this problem. So here we have capital M for the mass of the sandbag, and multiply by the gravitational force to calculate the gravitational, multiply by gravity to calculate the gravitational force. And here we have the tension from this side. طيب, when the actor reach this point, let me change the color. So what will be the forces? So I draw the actor. Now this is the actor, and the actor is moving. So that means he has, at this point, he has mg, the gravitational force. And now, because he is moving in a circular motion, we have a centripetal force that is equal m v square over r. And at the opposite side we have the tension. So now we have two equations to write. So the first equation is T equal mg plus m v square over r, and m is the actor mass. The initial and final height will matter. Now you will see, Saeed. But let us write the equations. Okay, and the second equation, which is in the blue line here.
Doctor,
تفضل.
you just left the theta out. Like, shouldn't it be mg cosine theta?
Where?
In this equation, in the first equation.
No, we are talking about this position.
Oh, at this.
At this position. At this position, we have just T is equal mg plus mv square over r.
Okay. But the acceleration is going upward though.
The
So it should be
acceleration.
like.
The
So it
acceleration.
should be like g minus mr.
No. We solved that before. We discussed that
In chapter
before.
6.
Yes. So because it's a
In the roller
centripetal.
coaster thing.
That's correct. That's correct. So when it
Okay.
is, when the acceleration, when the centripetal acceleration is pointing in a direction, then the force acting on the object would like to resist that force, so it will be in the opposite direction. Just go
So
back
the acceleration is in the opposite direction. To be honest, doctor, I never understood the roller coaster thing. But okay. Yeah.
Well, I will tell you an example. You are in the car. The car is moving and then you press the brakes. Where is the acceleration?
Acceleration is backwards.
Backward. And if I want to calculate the force of your body acting on your body,
Yeah.
the force will
Forward.
be backward.
Backwards as well? Okay.
Correct? Yeah, the force is backward, but
Yeah, but your
every
body moves
action,
forward.
every action are opposite and equal and opposite reaction. So
Okay.
your body will move forward with that force.
Yeah. Okay. I'll try to think.
Always, the body will move against the acceleration applied to the body. Always, except
Okay.
for gravitational force, and gravitational force is not because of motion, it's because of mass.
Yeah.
But if you have any other force, always the object will react against the force applied to that object.
Okay, how about the y initial? What would the question be if it was like the y initial? Same thing, but mg cosine theta?
Yeah, but at y initial, like when he just starting to move, then v is equal 0, so centripetal force is equal 0. So you have only the component of mg.
Centripetal force for the actor is 0?
Yeah, when he starts moving.
Oh, so right now he is constant.
Yeah, at the beginning, v is
Oh.
equal 0, so mv square over r is 0, and you have only the component here at this point.
How about if he was moving? If he was moving in y initial, what would the acceleration direction be? Up, right? Not down.
Well, it will be towards the tension.
Okay, so it's like opposite of the y final.
هلا if you revise chapter 6, we never talked about in between. We talked at the bottom and we talked at the top, but we never talked about in between. This is why you are confused. And in this
Yes.
problem, he is
Right.
not asking you in between. He is asking you at the bottom.
Okay, so in between, like, is it advanced?
Well,
Okay,
yeah,
basic.
in between it will be like you need to analyze the acceleration. You need to analyze the centripetal force, and you need to analyze the gravitational force. But
Yeah,
that's
okay.
we didn't cover that. We
Okay.
cover
Great.
only that you are at the
Mm.
bottom or you are at the top, just to make things easier.
Okay. A
So
bit tricky.
what's confusing you, and you are missing the point in what will happen in between, but we didn't cover it in between, just to make things easier. We covered at the
Yes.
bottom and we cover at the top.
Okay, great. Thank you.
Okay? So we come back to our equation. So at the bottom, we have the tension is the mass of the actor plus the centripetal force acting on the actor. طيب. Now let's write the blue. And if you are still confused, just go back to chapter 6 because we spend enough time there to explain it. No, mg is not equal to mv square over r. No, mg is not equal to, because if mg is equal, because you have a tension term here. You have a tension still there. In direction, no, mg and mv square are in the same direction. Refer to chapter 6 لأنه we spend we took our time to explain it. Those are quantities يا شباب, not vectors. Those are quantities, not vectors. You are confused because you need to start as a vector and then minus sign and plus sign will be clear. Now let's talk about the blue equation. T is equal capital M G, and capital M is the sand mass. So this is equation 2 and this is equation 1. So then we can write capital M G is equal mg plus mv square over r. طيب, so that's when we analyze the forces. طيب, let's analyze now energy wise. Energy wise. So you look here. Energy wise, this actor moved this distance. Moved this distance. طيب, what are the equation? Well, we have mgh is equal half mv square. So right away, m will disappear. So what we have v square is equal to gh Okay, but what is H? Now let's talk about H. Let me draw it so we can see it. So this is theta and this is H. So this is R, this is also R, and this one R cosine theta. So that means H is equal R minus R cosine theta. يعني H is equal R في 1 minus cosine theta. Any question here about H? So we have R here and R here, and the change in kinetic energy must be equal mgh. But what is H? Well, it is R cosine theta minus R. Shall I move? No, wait, okay. Yeah, the change in potential energy, which is equal to the change in kinetic energy, is mgh. But what is H? Well, it is R minus R cosine theta. This is R, and this is R cosine theta. Yeah, he gave you the R is 3 meters. Okay. So then I go back to my equation. So then V square is equal to G. And then I replace H by R, 1 minus cosine theta. So now I replace V square, this is V square, I will just replace it here. So then this equation is mg, small mg, plus small m, 2g, r, 1 minus cosine theta, over R. So R will disappear. So then mg is equal mg. So are you with me? Like now it's just calculus. Now it's just calculus. Where is the physics? The physics is equation number 1 when I calculate the tension. The physics is equation number 2 when I calculate the tension. And the physics in concept that potential energy is converted into kinetic energy. So that's the physics. Those 3 things. Now the rest is calculus. Just use your calculus and how to manipulate an equation, and then you end up with the final result. But where is the beef in this problem? The beef in this problem is not mathematical manipulation. The beef in this problem, equation 1, equation 2, and the concept of potential energy to kinetic energy. The rest, we just manipulate your experience in mathematics and calculus and whatever. Of course. يعني for example, if this problem, if this problem will have 8 marks, I will give 2 marks for equation 1, and 2 marks for equation 2, and 2 marks for the concept of mgh is equal half mv square, and the rest of the calculation I'll give 2 marks. Because the beef, the physics, is in equation 1, equation 2, and the concept of conservation, of course, 6 marks for physics concepts. The rest, if you do mistake after that, I will just be very merciful. I'll be very tolerant. I will not deduct a whole of marks if you do a mistake after that. But you have to do the physics part correctly. So imagine, if you write this equation, you will take 2 marks. If you write this equation, that's 4 marks. If you write the concept correctly, that's 6 marks. The rest I will give 2 marks. لأنه it's a physics course, and most of the marks will go for applying the physics concepts into a problem. The rest is, as I told you, calculus or algebra or whatever. But from my side, there is a lot of beef in the physics, equation 1, equation 2, and the concept of converting potential energy to kinetic energy. Now we just go through manipulating our problem to find the final answer. So plus 2 mg 1 minus cosine theta. So then m capital G, m small g is equal to mg 1 minus cosine theta. I will just, because he asked me for cosine theta, what will be the maximum angle. So I'm just reorganizing my equation just to solve cosine theta. So you can do whatever mathematics in order to reach that. So I will just solve it my way. And then cosine theta will be, let's go. Do you want me to go step by step with you? Okay. So So that means cosine theta is equal 1 minus capital MG. G will be cancelled. So cosine theta is equal 1 minus M minus small m over m. We put the number, so 1 minus 130 minus 65 over 130. So it's a half. Means theta is equal 60 degrees. Yeah, it's 2. So if this problem in the exam, all this will have 2 marks, this will have 2 marks, this will have 2, and this will have 2. That's correct. If the actor start from an angle higher than 60, when he reach the point, the sand will move. The sandbag will move up. Okay, so let me tell you an example. The student in the exam wrote equation 1 correct, equation 2 correct, and the concept of converting potential energy to kinetic energy correct, and then he stopped at this point. He stopped here and he wrote for me, Doctor, I don't know how to calculate H. He will get 6 out of 8. I will give him 6 out of 8. طيب, other scenario, he wrote this equation wrong, and this equation wrong, and this equation, the concept is wrong, and then he did all this calculation perfectly sound. He will get 2 out of 8. Because I teach physics, I don't teach math. And I will not give you a lot of penalty if you have a mistake in math, not in this course. Well, heavy penalty will be for physics concepts. So this is how I mark. This is how I mark, because it's a physics course, it's not a mathematical course. So try to change your method of thinking in the final exam, inshallah, because I will look for physics concepts in the problem, not for very long mathematical calculation. Because it's a physics course. So pay attention for, inshallah, in the final, that most of the mark will go for physics concepts and how you apply them to the problem. Physics concept and how you apply them to the problem. طيب, now let's talk about situation involving kinetic friction. شو معنى kinetic friction؟ يعني we have a loss of mechanical energy. Again, when we say mechanical energy, معناته it's a conserved, we are talking about conserved forces. Mechanical energy, potential energy, elastic energy, kinetic energy in the future, rotational energy, all those we call conservative forces, and we call mechanical energy. Now, when we talk about friction, we lose mechanical energy. طيب يا أستاذ, we lose mechanical energy, that is correct, but still the total energy is conserved. The total energy is conserved. Heat, sound, whatever. But part of the energy is lost. The total energy is conserved. Yes, mechanical energy is not when we have friction, but the total energy is still conserved. Exactly. That's the main concept in this chapter. So, situation involving kinetic friction, that means we lose part of our mechanical energy. Well, before, if you still remember, we wrote work is change in kinetic energy, work is change in potential energy, work is change in elastic energy. If this is when we have conservative forces, now we have friction, so we write it the same, work minus work done by friction is equal change in kinetic energy. Work minus the work done by friction is equal potential energy. Work minus work done by friction is equal change in elastic energy. So it's the same, but now we need to consider friction. We need to consider friction. So we are familiar with those three equations. Now the new thing, we add friction. But it's the same concept, but now we are not talking about mechanical energy, conservative forces. We are talking about mechanical energy with non-conservative forces, such as friction. Clear? طيب, هلا لاحظوا انه الفريكشن فورس mostly will cause heat to the object. What is heat? Well, it's a change in the internal energy. So the object, we have friction is heat, so that heat will be transferred to the object, for example, transferred to the surface. So we say the total internal energy of the system. So the loss of conservative mechanical energy, the loss will go into internal energy. So the object will become hotter, for example. The surface will become hotter. طيب, I need, hotter عادل. I need somebody to read for us this problem. So I can drink my coffee. تفضل يا عادل.
All right. So at 6 kilogram block initially at rest is pulled to the right along a horizontal surface by a constant horizontal force of magnitude 12 newtons. Part A. Find the speed of the block after it has moved 3 meters if the surface and contact have a coefficient of kinetic friction of 0.15.
طيب. So now this is completely new for us. We never saw that before. He gave us the mass of the block. He gave us the force of horizontal surface by a force which is 12 Newton, and he gave us also the coefficient of friction. So let's write down our equations or our first information. So he gave us the mass is equal 6 kilogram. He gave us the force, which is 12 Newton, and he gave us mu of kinetic energy, and he gave us the distance, which is 3 meters. And what he is asking, find the speed of the block after it moved 3 meters. Well, here is our approach. Work done is equal, and this is the net work is equal our force multiplied by the distance minus the force of friction multiplied by the same distance. And this is our mass. So we have our force acting in this direction. We have our friction force acting on the opposite direction. And we have mg, and we have our normal force. It will take just 2 minutes, yeah, Adil. Just 2 minutes. So that means 12 multiplied by 3 minus 0.15 multiplied by m, which is 6 kilogram, multiplied by the gravitational acceleration, multiplied by 3, the distance. So you put the numbers, 36 minus 26.46, that is 9.54 joule. So that's the net work, because the friction is lost. Yeah, it's the friction is lost. So that net work will be converted into kinetic energy. Change in kinetic energy, يعني change in kinetic energy is equal half mv square is equal 9.45 joule. Well, we have the mass, so that means v square is equal 9.54 over 2 multiplied by m, and 9.45 divided by it's half here, it's half m, so 2 will go up, so 2 will go up, and here we have a 6, so that is, so that would be 9.54 over 3, 1.78 meter per second. So let me stop here.